Guess who's back, ladies and gentlemen? Yes, yes, you know it is. It is I, Mr. Llanos, back again with a flipped geometry lesson. We're doing lesson 4-3. We're going to be talking about congruent triangles. More of this triangle stuff. I told you chapter 4 is all about triangles. After this lesson, you'll be able to name and use corresponding parts of congruent polygons. And you'll be able to prove that triangles are congruent using the definition of congruence. So we've already talked about the word congruent and the idea of congruent when it comes to line segments and angles. But now we're going to talk about polygons. If two geometric figures have exactly the same size and shape, that's important, the same size and shape, we could say that they are congruent. This little chart here that you have in your packet is, as well, we could talk about these three figures here. They're not really polygons because they have a curved shape there, but they look like a fish. Let's call them little fishes. While they look to be different, they are positioned in different ways. 1, 2, and 3 are exactly the same size and shape, so they would be congruent. Now these here, figures 4, 5, and 6, they have the same shape, but not the same size. I'm sorry, 4 and 5 have the same shape, but not the same size. And 5 and 6, same size, but not the same shape. Because they don't have both of those things, none of these guys can be congruent to one another. Now, two polygons are congruent if and only if, again, if and only if their corresponding parts are congruent. What are corresponding parts? Well, let's think about it. If we have, let's take a look at triangle ABC here. Okay, we've got line segment AB, and that one is congruent. If you look, it's got a one dash here, so there's the congruent mark for JH. That guy is congruent to JH. Okay, now we've got, let's go with C or BC, and that's congruent to JK. Okay, and the last one, CA, and that one's congruent to HK. We've also got to talk about the corresponding angles in these two congruent triangles. So we've got angle A, and that one, since it has two, we got to look on this one. That's H, angle H. We've got angle B, and that's congruent to angle J. And the last one is going to be angle C, and that'll be congruent to angle K. So these are the 6 pairs of corresponding parts. That one there, and then the rest of these. So again, two polygons are congruent if and only if their corresponding parts are congruent to each other. The last thing we want to talk about is writing a congruent statement. So now we know these two triangles are congruent to each other, but how do we write a congruent statement to state that? So I'm going to start by just writing one of the triangles. Triangles A, B, and C. And that's going to be congruent to triangle. Now, we start off, if we have A here, we need to look for the angle that is congruent to A. And since we just said a second ago it was H, we start with H. And then B is congruent to J. And lastly, it's going to be K. Okay? The position of the letters that you use to write a congruent statement have to be in order. So A, again, is congruent to H. B is congruent to J. And C is congruent to K. I wouldn't be able to write triangle ABC is congruent to triangle JHK. Just doesn't work, because if I look, A is not congruent to J. I wouldn't be able to write it in that order. Now we want to show that the polygons are congruent by identifying all of the congruent corresponding parts. Then write a congruent statement. First, there is a mistake in this figure here. If you notice, there are 3 lines here and 3 lines there. Also, 3 lines here and 3 lines there. We're going to add another congruent line right there. and 1 right there for the purposes of this problem. We're going to start by listing all the congruent, the corresponding sides. Here, we're going to start with the very first one. Let's go in order. We'll do PQ. Okay, and that's going to be congruent to GF. Next, we've got PS here, and that's going to be congruent to GD. Now, EF, and that'll be congruent to QR. And lastly, we've got SR, and that's going to be congruent to DE. Now, if we're looking at the angles, I can start with angle P, and that's going to be congruent to angle G. Angle Q is going to be congruent to angle F. Angle R will be congruent to angle E. And angle S is going to, that's a funky congruent sign. Sorry, that's just ugly. It's bothering me. Sorry, I got to fix it. Angle S will be congruent to, yep, angle D. Now, the congruent statement that we're going to write, again, doesn't matter. Let's start with this guy up here. Doesn't matter. This will be quadrilateral. We'll just write the letters out. We can start with P. Let's go clockwise. P, Q, R, S will be congruent to, we've got to start with the same, with its corresponding part. So P is G. We can go down the line because Q is going to be F, E, D. Okay, any one of these, if we look, we can look in this congruent statement to find any of these. So let's start with PS or PQ. PQ, though it's in that position right there, is congruent to GF. It's in that position right there. If I were to look at PS, I go from the first position to the last position, it's congruent to GD, first position to last position. Okay, that is the correct congruent statement. PQRS is congruent to GFED. That's where we get the idea for CPCTC, which just means corresponding parts of congruent triangles are congruent. So if I were to tell you that triangle RTS is congruent to triangle XZY, just by this congruent statement, you'd be able to tell me a bunch of different things about these two triangles. Automatically, you can mark that RT is congruent to XZ, TS is congruent to ZY, RS, now we're looking at RS, is congruent to XY. The same thing with the different angles. Angle R and angle X are congruent. Just going to do that. Angle T and angle Z are congruent. And S and Y are congruent. I'm just going to use 3. 1, 2, 3. And 1, 2, and 3. Now in this diagram, triangle ITP is congruent to triangle NGO. If we look at ITP, we've got all the angle measures, all the values for the angle measures, and the values for the side lengths. Now in NGO, we just have a couple things with variables, and we need to figure out what X and Y are. Since this one up here has X minus 2Y, we're not going to start with that one. Let's start with 6Y minus 14. And what's that going to be equal to over here in this triangle? Well, if we look at the congruent statement, O is congruent to P. So this angle O is going to be congruent to angle P, which is 40 degrees. Now we can go ahead and write our congruent statement, or sorry, just an equation, 6y minus 14 equals 40. And now we can solve for y. Add 14 on both sides. 6y equals 54. Divide by 6 on both sides, and y equals 9. So we just found y. Now we can use what we know from y, plug that in here. Also, we got to look for the value for ng. ng is x minus 2y. But what is ng congruent to? The first two, it'd be it. That's the first two on the other side. If I can draw a line right there. And it is equal to 7.5. So now I can draw or create another equation. X minus 2y equals 7.5. But we know that y equals 9. So x minus 2 times 9 equals 7.5. X minus 18 equals 7.5. If I add 18 to both sides, x is going to equal 25.5. So here's your value for y, and there's your value for x. Just a few things I want to talk to you about as far as congruent triangles go. And the first one is called the third angles theorem. And like it says here, what it means, if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of those triangles are congruent. So we've got two sets of angles here, C and B, congruent to K and J, which basically leads us to say that these third angles are going to be congruent. Even though we don't know the measures or if they're congruent to anything else, the third angles theorem tells us that this is so. The next thing I want to talk about is called the reflexive property of triangle congruence, which basically says that triangle ABC is congruent to triangle ABC, which means that triangle ABC is congruent to itself. Now, while it may not make a lot of sense now, there will be some problems later where this will come into play. Next, we've got the symmetric property of triangle congruence, which basically says that if triangle ABC is congruent to triangle EFG, then we could also say triangle EFG is congruent to triangle ABC. Lastly, we have the transitive property of triangle congruence. Now, this one uses all three of these figures here, so let's follow along. We've got triangle ABC, this one here. If I can highlight it, triangle ABC is congruent to triangle EFG. And then if EFG is congruent to triangle JKL, so again, we made a connection between this one and this one. And then we said this one here was congruent to this one here. The last thing we can say, because we know these first two things are true, we can automatically say that triangle ABC is then congruent to triangle JKL, which basically means that all three of those triangles are equal to each other. I'm sorry, not equal, but congruent to each other. All right, that's the notes for lesson 4-3, congruent triangles. This was a longer one. It's about 15 minutes long, so I would definitely watch it again. Make sure you go over the notes and write down any questions you may have. So when you see me in class, you are ready to go. All right, peace. And the magic word is pineapple.